Welcome back to another video, guys, and today we're going to be taking a look at this really interesting logarithmic question from May-June 2025 question paper 1-1 of question 8b. And the reason I found this so interesting is because to solve this question we need to employ a whole lot of logarithmic identities. So let's just dive right into it. So we can say, let's start off with log base 5 of 12x minus 4 is equal to 6 upon log of x, and we can write the 125 as 5 cubed plus 1. Now here we have our first logarithmic identity. Note that log of base a of b to the power n can always be written as n times log base a of b. So what we're basically going to do is bring the 3 down and have the power of 5 be just 1. So we have log base 5 of 12x minus 4 is equal to 6 upon 3 log x 5 plus 1, and see 3 and the 6 cancels out, so we have log of 5 12x minus 4 is equal to 2 upon log base x of 5 plus 1. And here we have our second identity, which states that log of base a of b is equal to 1 upon log of base b of a, right? So let's keep the left hand side as it is. So log base 5 of 12x minus 4 is equal to 2 upon, now let's switch out the log base x so that x becomes the argument and 5 becomes the base. So 1 upon log of base x of 5 plus 1. Great. Now let's simplify this further. So log base 5 of 12x minus 4 is equal to 2 log base x of 5. Oh, my bad. We have to switch these out. So log base 5 of x, log base 5 of x plus 1. Alright, so now we use the power rule, remember? Now let's use the power rule in reverse. Let's bring the 2 up to the power of x. So we have log of 5, log base 5 of 12x minus 4 is equal to log base 5 of x square plus 1. Right. Now let's take the log base 5 of x squared to the left hand side. So we have log 5 of 12x minus 4 minus log base 5 of x squared is equal to 1. So now let's introduce two identities. The first, log base a of b minus log base a of c is equal to log base a of b upon c. This is our first identity. The other identity is log base a of a will always be equal to 1. Alright, so see here, the bases are the same. So the arguments, we can divide the arguments. So we get log of 5, log base 5 of 12x minus 4 divided by x squared is equal to, now instead of writing 1, we can write this as log base 5 of 5. And I think you see where I'm going with this now. The logs cancels out. So we're left with 12x minus 4 upon x squared is equal to 5. Let's expand this out. We have 12x minus 4 is equal to 5x squared. Let's get everything on one side. So we have 5x squared minus 12x plus 4 is equal to 0. Now it's just a case of middle term breaking. So we have 5x square. Factorize this. We have minus 10x minus 2x plus 4 is equal to 0. Let's take out 5x as common. X minus 2 minus 2 x minus 2 is equal to 0. So we get x minus 2 into 5x minus 2 is equal to 0. Therefore, our answers are x is equal to 2 and x is equal to 2 by 5. Now we're technically done with the question. However, it's always good practice to see if we have any constraints in the question. So let's move up and take a look at the question again. The question states that log base 5 of 12x minus 4 is equal to 6 upon log x of 125 plus 1. This all makes sense. However, I want to draw your attention towards this. The argument of a log can never be negative. So 12x minus 4 always has to be greater than 0. So let's do that. Let's solve that and see what we get for x. So what we had was 12x minus 4 has to always be greater than 0. Therefore, x has to be always greater than 1 upon 3. And in this case, it doesn't matter because both our values are greater than 1 upon 3. But if we found x to be lesser than 1 upon 3, then we would reject that value because it does not satisfy our question and it's a false value. So there you have it. Our answers are x is equal to 2 and x is equal to 2 upon 5. I hope you enjoyed this question as much as I did, and I'll catch you in the next one.